TClark here, and this video is going to go over the ClarkMath sequence I made to help you out for the final. And in this question, we have a sequence of numbers, and if n is a value of a term in the sequence, the next term is determined by these following rules. So the rules are these 3 bullet points. So if n is less than 4, the sequence terminates. So no more number, that's the last number. If n is a multiple of 4, then the next term is n divided by 4. Otherwise, the next term is 2n minus 8. So here we go. Here's my example. So if n is n9, if n is 9, it's not less than 4. It's not a multiple of 4. So I have to do this 2 times n. So 2 times 9 minus 8. So that's 18 minus 8, which is 10. So the next term is 10. So the second term is 10. Is not less than 4. Is not a multiple of 4. So I do the math again. So 10 times 2. 2 times, I should put 2 in front. Oh well. Yeah, I probably should. I'll do that eventually, maybe, if I remember after this video. But either way, 10 times 2 is 20 minus 8 is 12. So my third term is 12. It's not less than 4. It is a multiple of 4. So I do the n divided by 4 math. So 12 divided by 4, which is 3. So the last term, the fourth term is 3. So it terminates and returns 3. So I should put and returns. But this is a copy, so whatever I do here won't change. So I just have to keep that in mind. Okay. So the same thing here, 16. If the first term is 16, it is a multiple of 4. It's not less than 4. So it's n divided by 4. 16 divided by 4 is 4. Then the next term is 4. 4 is not less than 4. So it is a multiple of 4. So I do 4 divided by 4, which is 1, which is less than, oh, there's your space here. It is less than 4. So I just return it. And then example 3, let's see, 13 is not a multiple of 4, not less than 4. So times 2 is 26 minus 8 is 18. And then I multiply, again, not multiple of 4. So multiply by 2 is what, 36 minus 8 is 28. It is a multiple of 4, so I divide by 4 is 7. And then 7 is not a multiple of 4, not less than 4. So multiply by 2 is 14 minus 8 is 6. And then 6 is not a multiple of 4, is not less than 4. So I do... well, it should be 6 times 2, which is 12. I was getting ahead of myself when I wrote that. I got to fix that. I got to fix that space. I got to fix a lot of mistakes I'm seeing. Returns n. Okay, so 6 times 2 is 12, minus 8 is 4. 4 is a multiple of 4. So I divide by 4, I get 1. 1 is less than 4, so I return it. And returns 1. A lot of little mistakes. Okay, so I have the final term method, which will return that final term using these rules. And then, so I'm going to do that. I'm not going to look at B and C yet. I'm just going to say, okay, so find the final term depends on, it doesn't return length of, it returns the number. So it returns 3 or returns 1. Yeah, so here we go. So I'm going to say, I'm just going to look at the bullet points. What do the bullet points say? If it's less than 4, so if n, which is num, is less than 4, return num. There we go. Got the first bullet point. Else, if it's a multiple of 4, so multiple of 4 would be n num, or n, well, num because it had to match this parameter. So num percent 4 equals 0, right? Multiple means it's divisible by, enter bracket, enter. So I'm saying if the number is divisible by 4, I'm going to say next term is n divided by 4. Okay, but I need to keep doing this. I notice right now, I'm like, okay, what am I going to do? How am I going to do this? So I'm going to say as long as while number is greater than 0. So wait. So I want to loop as long as, I want to keep going as long as it's bigger, let's say bigger than or equal to 4. As long as it's greater than or equal to 4. and then I need to return it at the end. So I'm going to return the number at the end if it's no longer bigger than 4. So I took care of this instead. So I'm saying loop as long as while the number is greater than 4, greater than or equal to 4. If it's a multiple of 4, then I divide by 4, and the next term is going to be that divided by 4. Else, I'm going to say what? The next term, the new number, equals 2 times the old number minus 8. Then I reordered it a bit. I said, okay, keep going as long as it's bigger than or equal to 4. I do these two parts. And then if it's less than 4, that's after the while loop. So if number is 3, 2, or 1, or 0, or negative, I guess. But if the number is not 4 or bigger, I'm going to return that number. And then that should work out. So if I run it, let's see what I get, see if I made any mistakes. Okay, I can scroll down because there's actually a table down here. I can double check. So it should be 1, 2, 3. Obviously, the first 3 numbers are 1, 2, 3. And then 1, 2, 1. And then 1, 2, 3. 7, 8, 9. Yeah, and then 10 is 3. 11 is 2. 12 is 3. And then 2, 3, 1 are my last ones. Okay, it looks like it's working. So there is my part A, final term. Again, the final term is just the number I'm returning. Everything else, I have to do the math. Either divide by 4 if it's a multiple of 4. If it's a multiple of 4, divide by 4 to get the next term, or else do that math 2 times n minus 8. So this problem might be worth 3 or 4 points. So 1 point for getting the next term correctly, maybe a point there, and then a point for getting the while loop and then returning. So 3 or 4 points getting all that stuff ready. Okay, let's look at B now. So in B, so I'm going to look at, I should have just done the shortcut. Oh well. B says, write the method same, int num1 and num2. So I have this same down here. I'm going to focus on just this now. Boolean, I need to return Boolean. I see that same int num1, int num2, which returns true if the ClarkMath sequence starting with num1 ends with the same final term as a ClarkMath sequence starting with num2. So same final term. Assume final term works. So even if I got A wrong writing it down on the test, I can use it and I assume it's correct. So I'm going to say if final term of num1 equals the final term of num2, return true. And then I'll actually do the whole full thing, and we'll see in a second what else you can do. Else return, what the heck? Return false. Okay, so returns the final term of a ClarkMath sequence that starts with, and wait, no, I'm on the wrong one. Returns true if the ClarkMath sequence starting at num1 and num2 end of the same term. End in the same term, so that's the same final term. And false otherwise. So then they give me, oh yeah, I forgot the precondition. I don't have to worry about the precondition, but n is always going to be a positive number up to 100. I don't know if it'll work for bigger than 100, but up to 100 worked well with my solution. So let's see if this works. So it's saying all these true and falses. Okay, so if I look at my table, if the starting number is 1, the final term is 1. And then what else? So 1 and 4 should be the same. So it should be true. 1 and 4 is true. They're both 1. 1 and 6 and 1 is 7. True and true. And then 1 and 13 are true. Okay, how about 2s? 2 and 5 should be true. It looks like it is. 2 and 8 should be true. Then 5 and 8 should also be true, right? 5 and 8. Yeah, so whichever ones are 2 should be true. And then 5, 8, and 11. 8 and 11 true. Okay, so it looks like it's working. This is the full way you could write it. You don't have to write it this way. So if you're returning something, you don't need the else. You could just say if they're equal, return true, and then return false is anything else automatically. Or you don't even need to have an if statement. We could just return the equals. This will be either true or false, so I return either true or false. So this might be a shortcut. Well, and then you need a semicolon, but this might be a shortcut to writing it with the if-else, return true, return false. So it's ever if something return true, else return false, you just return that something right away. So that's a shortcut you can do in the future. Okay, so now we're on part C. C says, I might have to scoot over a little bit, just a little bit. I wanted more code, but I need to read this. So the method prop same. So here we go. Prop same is returning a double IC is given a K number and a num1. So that might be the start, and then K is something else. Let's see. Returns a proportion. So proportion is like a percentage of ClarkMath sequences with starting values between 1 and K. So the starting value is the number we start with, inclusive, which match the final term for the ClarkMath sequence starting with num1. So consider the following table which provides data about the ClarkMath sequences starting values between 1 and 13. So here we go, 1 to 13 starting values. The method ClarkMath prop same 13.5 returns 0.3077 rounded. Since 4 of the 13 sequences, so I have 13 sequences, that's what the K stands for, have the same final term, which is 2. I got 2 because it's the final term of 5, so it's the same as the final term of 5. Whatever is the sequence starting with 5, which in this case 2. So I'm looking for however many 2 is, and I do the math, and there we go. So I think I need to loop 13 times, but not 13. 13 is K, so I need to say for int I equals 1. So I have to actually use the numbers here. So I can't just start at 0 now. I have to say, okay, I'm going to starting at 1. I'm going all the way to including 13. So I need less than equal to, since I'm including, I'm going by 1, so it's I plus plus. So I'm looping through. I need a double. Oh, I forgot my double, so I always want to start with double result. I'm counting, so result is 0. And what am I counting? I'm counting if they're the same. So if same, and I can just call same right here. If same of what? Just a number and the 5. Oh, but 5 is num1. So I'm going to say same of I and num1. So if 1 starts the same as 5, has the same final number as 5 does, if 2 has the same number as 5 does, if 3 has the same number as 5 does, if 4 has the same number as 5 does, if 5 has the same number as 5 does, so one of them is going to be true no matter what number. And then if 6 has the same number as 5 does, 7 has a number, so it's going to be dependent on whatever this number is. In my example, it's 5, but I don't want to use 5. I want to use my parameters here, 13 and 5. I'm just saying that, but I'm actually using K and num1 as my parameters. So what do? If they're the same, I'm going to increment my result. You could have used count, but I use result. Okay, so I'm adding up to my result, and then what I want to do, I want to find the proportion. I need to do the math. So I have my result, then I'm going to divide by, I messed up everything there. What the heck, I can't focus. Okay, so I want to divide by 13. 13 again is my number I'm given. So I'm going to say result divided by K, and then return result, and that should be it. Again, the numbers are positive, and actually K should be less than 102. Oh well. So if I run it, I should get that 13, which is 0.30303. Wait, did I uncomment? I did not. It says uncomment. What did I just do? I'm trying out Visual Studio. Oh, there it is. 0.30769. So whatever. So it's 77. Rounds off. So it looks like it works. So here is the prop same. I get my counter variable, loop through the K, including K, see if they're the same. I don't have to do any other stuff here. I just call the same. Should not be doing equals because it says you must use same appropriately. So I'm using same, and then I increment result, and I divide by however many there are, and since it's already double, it's set up to return. Okay, that's it for ClarkMath sequences. Have a good day. Where do I stop this?